In this video, we're going to do some general cleanup tasks for the whole state machine, and we will also build out a basic map system that allows us to generate parts of the tile map from script instead of needing to draw everything with the tile palette. Let's start by including a missing transition to our climb state. We want the player to be able to transition directly from climbing into the hang state. We can include an if clause in the update method that checks to see if the player is entering an up input while their ledge trigger property is also true. In this case, we'll simply transition them directly into the hang state. Let's quickly test out this new transition. We should be able to climb up this ladder and then move directly into the hang state and climb the ledge at the top of the ladder. It looks like that transition is working correctly. Now let's move into setting up our map system. We will start by defining a new setting that allows us to set a starting position for our player. Then we will create another setting that establishes the overall boundaries of the stage. We will create a bounds object that defines this boundary. It'll be centered at the origin of the scene, and then its size will be the overall width and height we want for the level. Let's now go to the player's start method so that we can set their position using the start position vector. If we run the application now, we can see that the player begins from the position we have defined. Now we can create a new script called map system. We will set up this class in a similar way to how we defined the input system, and it will also be managed by the game manager class. Let's include a reference where we can store the game settings object, and then we'll also include a managed awake and start method. Let's also make sure to load the settings object in the awake method. In order to make changes to the map, we will also need references to the tile maps. Let's add a variable to store the overlay tile map, and then we'll also include a tile reference so that we can add new copies of this tile to the map. In the future, we would want to define a dictionary of all the tiles we are going to use in the map system, but for now, we are only going to use this single tile. We will retrieve the overlay tile map by finding the game object it is attached to and then using getComponent as we usually do, and then we'll load the tile like we do with any other resource from our resources folder. Now let's define a private method where we will use this tile to draw a boundary around the level. We will use a nested for loop to iterate over the boundary of the map. We will use the level bounds object that we defined in our settings to set the initial and final values for the for loop. And then we will define a Boolean variable that checks to see if the current position is actually on the border of the map. This will be true if either the X or Y value is on the maximum or minimum of the level. If the position is on the edge, then we'll use the setTile method in the tilemap class to add our boundary tile to this position. Let's make sure we also call this method in start so that it runs when the map system starts up. We will add the map system component directly to the game manager class like we did with the other systems. Now we can move to the game manager class so that we can also include our map system into the managed systems. We will introduce a reference to the map system and then retrieve the component in the awake method. We will also call its managed awake method after storing the component in our variable. Then we will also call the map system start method in start. Before testing this out, we better make sure to fix the infinite loop that I accidentally introduced while writing the nested for loops. This second condition should rely on the y value, not the x value. And it looks like I also need to reattach the map system to the game manager because I lost it when Unity crashed due to the infinite loop we just fixed. Now we can test out the map system. It looks like we've got a nice border on the tile map that is defined by these pink dot tiles. Let's also include a maximum fall speed into our settings. This will ensure the player reaches a terminal velocity if they fall a very far distance. We can apply this limit by simply using the max function whenever we set the player's velocity. If the y value being set is larger than the max fall speed, we will default to the maximum. This means we will never set the y speed to anything larger than the max fall speed. If you're keeping track closely, you'll notice I used a negative value for the speed here again. instead of insisting that all speeds be positive values. The last thing we're going to do is actually enforce the level boundaries. If the player moves beyond one of the edges of the level, we are going to transport them back to the start position we defined earlier. We can do this by adding a new clause to the if statement in the move state's update method. If the player is not contained within the level bounds object, then we will reset their position to the start position. We will also put them into the move state and reset their facing and velocity values. Before we test the boundary, let's increase its size so that it contains our whole stage. First, we'll update the value in our game settings script so that it always defaults back to the new value, but then we'll also update the value in the current settings object to make sure we actually see it in the game now. Careful with updating this because in the inspector you're setting the extents rather than the full size vector. Let's go ahead and test out the level boundary now. It looks like the player is reset to the start position whenever they exit the boundary exactly as we wanted. This completes the first series of the player controller tutorial. Please feel free to suggest new features that we can continue to add to this controller in the comments. I will be happy to continue extending the controller and adding new videos to explain the new features. Thanks for watching.